Welcome back to my channel. In this video today, we're going to talk about the factor theorem. Okay, so what exactly is the factor theorem? So the factor theorem says that for any polynomial f of x, x minus k is a factor if and only if f of k equals 0. Alrighty, so the if and only if means that the conditional goes both ways. That means if x minus k is a factor, then f of k equals 0. That means that k is a 0 of the polynomial, but it also goes the other way. If f of k is a 0, then x minus k is a factor. So what is this saying? This is saying that if we have a 0 of the polynomial, then x minus that 0 is a factor, and vice versa. If we know that x minus 0 is a factor, then we know that f of k is at 0. Or if we know that x minus k is a factor, then we know that f of k equals 0, which means k is a 0 of the polynomial. So let's work some examples. Let's see how this would play out. Okay, in this first example, we want to determine whether x minus 1 is a factor of this polynomial, f of x equals 2x to the 4th plus 3x squared minus 5x plus 7. So in this case, if we think about the factor theorem, what it just said, it said x minus k is a factor if f of k equals 0. So we could do one of two things. We could put a k in here and work it out to see if it comes to be 0, or we can use synthetic division with k equal to 1 and see if the remainder is 0. So I want to use the synthetic division. To me, I think that's easier, but you can plug in 1. Plugging in 1 may not be as hard. But in this case, this is x minus k. So k is actually 1. So one thing you want to remember, whenever the number is with x, you're going to change the sign on it to get the value of k. If the number is not with x, you keep it the same. So I'm going to do synthetic division with k equal to 1. My coefficients would be 2. There's the x to the third missing, so that would be 0, 3, -5, and 7. And so if I do synthetic division, drop the 2 down. 1 times 2 is 2. Add the 0 and the 2. And that's 2. 1 times 2 is 2. 3 plus 2 is 5. 1 times 5 is 5. -5 plus 5 is 0. 1 times 0 is 0. 7 plus 0 is 7. So the remainder is 7. So that means that f of 1 is equal to 7. And my marker's running out. F of 1 is equal to 7. That's not 0. So then we will say that x minus 1 is not a factor. So this would have had to be 0 in order for it to be a factor. So that's how you will work that example. Okay, for example 2, we want to factor this polynomial 6x to the third plus 19x squared plus 2x minus 3. We want to factor it into linear factors given that -3 is a 0. And so what we want to do is, since -3 is a 0, then when I do synthetic division, then I know by the factor theorem, the remainder is going to be 0, or I know that f of -3 is going to be 0. But also when I do synthetic division, it will allow me to know what the other factor is. So I'm going to do synthetic division with k equal to -3. My coefficients are 6, 19, 2, and -3. So this is 2, -3, 19, and 6. All right, so I'm going to drop my 6 down. And -3 times 6 is -18. 19 minus 18 is 1. -3 times 1 is -3. 2 plus -3 is -1. -3 times -1 is +3. Add those together, you get 0. So we knew, because that was a 0, that the remainder should be 0. But this tells us, since f of -3 equals 0, then by the factor theorem, we know that x minus a -3 is a factor. Well, what is x minus a -3? That's x plus 3. So x plus 3 is a factor. This tells us what the other factor is. So this was a third degree polynomial divided by a first degree. So that means this is a second degree. So this is 6x squared plus x minus 1. So this polynomial factors down into this, but we want all of our factors to be linear, and this is actually a quadratic factor. So that means now we need to factor this 6x squared plus x minus 1. In order to factor, and I'm right over here, 6x squared plus x minus 1, we have to do, we have to factor to where we multiply the a and the c. So a times c is 6 times negative 1, which is negative 6. So now we want to take factors of negative 6 that add to a positive 1. So the positive 1 comes from the coefficient of the middle term. So what are two things that multiply to give me negative 6 but add to give me positive 1? That would be 3 and negative 2. 3 times negative 2 is negative 6. And 3 plus negative 2, which is the same as saying 3 minus 2 is 1. So that means that this factors into x plus 3 times x minus 2. And because there was a number in front, this is the shortcut method for factoring, you will divide each of those by that 6, that a. And then this will simplify to x plus 1/2 and x minus 1/3. Now, anytime there is a fraction, so this is definitely correct. You could write it like this, but on your homework, if you're using My Math Lab by Pearson, it is not going to allow you to enter the fractions here. So what you have to do is take the number in the denominator and write it as the coefficient of the x. That's anytime you have a fraction. So this would be 2x plus 1, and this will be 3x minus 1. So now if I rewrite this in completely factored form, I still have the x plus 3. Now this 6x squared plus x minus 1 factors into 2x plus 1 and 3x minus 1. So this will be your final solution. Now you've taken this function, you factored it into linear factors. So what did we do? We started by dividing negative 3 using synthetic division so that we could get the other factor. Because f of negative 3 is equal to 0, then x minus negative 3. So whenever you put it with the x, you change the sign. So that becomes x plus 3 times this 6x squared plus x minus 1. This is what that factors into. And because these weren't linear factors, we have to factor this down again by doing the AC method, or the shortcut to the AC method, multiply a times c, which is negative 6. Find factors of negative 6 that add to the coefficient of b, which is 1. And then once you find those factors, you have to divide them by the a. And we have the fraction, so we have to take the denominator and move it to the front. All right, so if you have any questions whatsoever, this was just 2 short examples showing you how to use the factor theorem. If any of it don't make sense, if you have any questions, feel free to include them in the comments below. If you haven't already, make sure you hit that subscribe button. And thank you for tuning in. I'll see you in the next video.